Hi everybody. We've gotten to the point now where we are building boats and we are now at the most important part of making the prediction for how much weight our boats will hold. Even if you didn't get a chance to build a boat, you are going to have to do this part. So please follow along and pause the video when you need to. This is my boat on the left. You can see the measurements there and you can see where I've found the volume. The volume is 90 centimeters cubed. That information is going to be really helpful when we try to predict how many pennies our boat can hold. So there's a science behind this. It's buoyancy. We need to make sure our boats can float, so that the science is about density and buoyancy. Feel free to tell Mrs. Bryson we're doing some science and math. This is the basic point. An object will float if it is less dense than the liquid it is floating in. The object will sink if it is more dense than the liquid it is floating in. Density, you're wondering, is just a comparison. It's a comparison of the weight or the mass and the volume. This is the formula we're going to use. We need to find the mass and the volume of our boats in order to determine whether it's going to float or sink. So density of water is 1 gram per centimeter cubed. That's how density is measured. The mass divided by volume of your boat needs to be less than 1 gram per centimeter cubed if your boat will float. Anything over 1 means that it's going to sink. So we already know the volume of my boat. It's 90 centimeters. That's supposed to be cubed. Now we need to focus on the mass of the boat. And by mass, I mean the weight. So I'm going to go over to Cami for a minute. Okay, so I'm in Cami so I can draw on the board here. I already have the formula set up. In order to find out how many pennies my boat can hold, I need to know the mass and the volume. I need to know everything I can, and I need to make sure that that fraction or ratio is less than 1. So this is what we're going to do. We're going to start filling in what we know. And the first thing I know is the density of water is 1 gram per centimeter cubed. I also know the volume of my boat, right? It was 90. The volume of your boat will be different, but this is the volume of mine. Now on top, I don't know if you noticed the last slide, but the last slide showed me weighing a piece of tin foil. And since we're all using the same size tin foil, and that's why I asked you to do that, we already know how much it weighs. And I'm going to put this in parentheses up here. It's 2 grams, okay, plus the weight of a penny. I'm going to just call that P. Now I've done some of the work here for you. I already know how much a penny weighs. So I know, here we go, I'm going to rewrite my formula again. The boat weighs 2, and each penny weighs 2.5. So every penny weighs more than our boats do. I'm going to put an X next to this because we don't know how many pennies we can hold. And I'll put this in parentheses. And on the bottom, I'm going to write 90. I'm not going to label for this part because I think it might get very confusing if I keep adding more letters in. The X is the variable. I'm looking for the number of pennies. Okay, so I know if I want this to equal 1 or be less than 1, this, any fraction needs to have the same numerator and denominator in order to equal 1. So I know this numerator must be equal to the denominator. So that's what I'm going to set it up as. 90 equals, and it's 2, which is the weight of the boat, plus 2.5 grams per penny. X is my pennies. Oh, look at this. It's a 2-step equation that you already know how to do. All right, let's refresh our memories here. I don't see any other like terms with a 2.5x. There are no other x's, so I can't do anything with that yet. But I can combine the 2 and the 90. Because they are on opposite sides of my equation, I have to do the opposite. So I'm going to subtract the 2 here, and I'm going to subtract the 2 here. That leaves me with 88. And the equal sign I should have written a little lower, equals 2.5x. This is all we need to do. We have a one-step equation now, and I'm going to divide both sides by 2.5. Okay, 2.5 divided by 2.5 is 1. I'm left with 1x, and I'm going to divide 2.5 on this side as well. Take your calculator and divide that. I'm going to pause the video, see what you get. When I divided 88 and 2.5, I got 35.2. That's how many pennies it should be able to hold. Well, here's a tricky little question. Can I put 2/10 of a penny in my boat? No. So it looks like if I put 35 pennies in, the boat should still be okay. But once I put the 36 pennies in, my boat will sink. You need to follow these steps to predict how many pennies your boat will hold. Good luck.